Yeah, so welcome to this class where we will discuss uh, maths, engineering mathematics questions asked in the GATE 2024 exam for electronics and communications engineering or EC branch. Okay, so first of all, uh, you know, this as far as the mathematics, engineering mathematics syllabus is concerned, there were around 3 markers in your uh, previous year question paper, and 4 were 2 markers. So total 8 marks were there, 3 plus 8. Okay, this number usually varies between 10 to 15. Okay, so that is why, like, this is considering only pure engineering mathematics questions. Okay, not any other type of questions. Uh, because in your technical subjects also you use maths, but we are not counting that part. We are just counting purely mathematics syllabus questions. Okay, so this highlights the importance of engineering mathematics for your GATE exam. So you should, if you are serious about GATE exam, you should always prepare well in your mathematics. Okay. So with that background, let's start. So I think there are around 7 questions, so we'll take one by one. And before we start the actual discussion, let me just clarify one thing, that in your GATE exam, it is from my own experience as well as many others students' experience, that most of the mistakes happen not because you don't know the concept. If you are a serious candidate, you will know how to solve some problems or what is the concept behind that question. But mostly the mistakes happen when you do when you try to solve the questions in hurry. Okay, so you see some simple question or easier question, and then you just jump on to solve the question without reading properly what is asked. All those things happen, okay, in the exam, because you are agitated or nervous in your exam, anxious. Okay, so that's why you should always carefully read the question first and then solve it. That is the general advice, not only relevant for mathematics subject but for all subjects. So with that, let's start. So this was question number 11, and the question is as follows: the general form of complementary function. So you should know what is complementary function of a differential equation is. It is given as at plus b e to the power minus 2t, wherein we are some real constants. Now you need to find the corresponding differential equation. So basically you need to reverse engineer in this problem. And since they are only talking about complementary function, which is also solution to the homogeneous part of your ODE. Okay, so homogeneous means the RHS should be 0. So that's why you would notice one thing: in all these options, they have given you RHS, which is some unknown function of t, f of t. So which is not required. The actual form of f of t is not required to solve this question. That's why they have not given it. Okay. So with that, let's solve this question. So now before we solve it, so there is there is a general solution to find, or general method to find complementary function of your second order ODE. You know, so you will have, let's say, for a second order ODE of the form, let's say y double dash plus some constant into y dash plus some constant into y is equal to f of t. Okay, so this is a general form of your second order ODE for finding complementary function. What we usually do is we take f of t as equal to 0, because then only your RHS becomes 0 and the equation becomes homogeneous, ODE becomes homogeneous. And then this characteristic, or sometimes they call it as axial auxiliary equation also, auxiliary equation, which is solved. Okay, so this characteristic equation is nothing but you just write this y double dash ay dash plus by equal to 0. This can also be written in terms of differential operator as d square plus ad plus b into y equal to 0, where d is nothing but d by dt. Okay. So this is a general representation of your uh, this thing, you know, ODE, and this characteristic equation. You just replace this d with some variable m, so this becomes m square plus am plus b equal to 0. Okay, so then you solve this, and let's say you get, since it's a quadratic equation, you will have roots, let's say m1 and m2. Okay, so depending on nature of these roots, there are three conditions. Okay, so first case would be uh, distinct real roots. So basically, depending on the values of a and b, if you get distinct real roots m1 and m2, then your complementary function becomes y equal to this thing, some constant c1 e to the power m1t plus c2 e to the power m2t, right? So this is first case that is possible. Second case is if these are repeated roots. So what I mean by that is m1, m2 are equal to some same value m. In that case, your complementary function is nothing but c1 plus c2t into e to the power mt. Okay, and the third case is in case your roots are imaginary roots of the form, let's say alpha plus I beta, then your complementary function becomes y equal to e to the power alpha t cos beta t. There will be some constant here, so let's say c1 cos beta t plus c2 sin beta t. Okay, so these three cases are only the possible cases. So now if you look at your solution, which is nothing but y equal to at plus b e to the power minus 2t, right? So that means it is the second case where your original ODE, when you write it in terms of its characteristic equation, it will have repeated root. Okay, so this y equal to at plus b e to the power minus 2t corresponds to repeated root case for the complementary function with this repeated root, let's say m as minus 2, right? Because e to the power minus 2 is there, so m is minus 2 here. Therefore, your characteristic equation uh, should be of the form. So you need to find a quadratic equation whose solution would be minus 2 and it will be repeated. So both the solutions should be minus 2. So it should be of this form, right? M plus 2 whole square is equal to 0. In that case only, m equal to minus 2 is a repeated root. Okay, so therefore your original or unknown ODE would be replace m with d, differential operator, into y equal to 0. You can write it as d square plus 2d plus 4 into y equal to 0. Okay, and then you can use this differential operator. D square means 2 time differentiation, right? So this will be d square y by dt square plus 2 into uh, dy by dt plus 4y equal to 0. So this is your original ODE, for which your complementary function will be of the form at plus b e power minus 2t. And if you go back and check the options, you'll realize that is the first option only. No, it will be 4. Okay, so it will be 2, right? 2ab. So here also it will be 4, and here also it will be 4. So therefore, you have option A. that is your answer to this question. Okay, so that is how you should solve this type of questions. And just to give you the whole idea about how to go about it, because next time they may ask you this question in a different form where they will change the nature of this complementary function. So in that case, as I said, there are only three possibilities. This time they asked repeated roots condition. Later on they may ask imaginary or distinct. Okay, and they may also ask you not only complementary function but also particular integral, because we know for ODE the general solution is nothing but complementary function, which is the solution to the homogeneous part, plus particular integral, which takes care of the heterogeneous part or non-homogeneous part that comes when you make your RHS not equal to 0. Okay, so that is how you should go about these problems. Okay, so I mean, I would encourage you to uh, find the original ODs for options B, C, D. We are not doing it here because of the time constraints, but that would be a good practice if you just find the original ODs for options B, C, D. Okay, or not original, sorry. You should find the complementary functions for options B, C, D, and then you'll have good practice so that next time you'll be in a better shape to handle these type of questions. Okay, so this was about one question from complementary function topic of vector calculus. Now let's go to the next question, which is nothing but as shown on your screen, question number 25. So here they have mentioned, and yeah, so they have mentioned that there is a function rho, which is xyz t, 4 arguments it takes. Similarly, u is also a 4 argument function, represents density and velocity. Okay, so these are common terms used for these two symbols, and they represent local density and local velocity because they represent these conditions at some point at some point xyz and time t. Okay, and then they have mentioned that del rho by del t is continuous, and let's say capital V is some arbitrary volume in a space enclosed by closed surface S. So maybe, so this will be a closed surface S, and this volume they are talking, they are denoting it by capital V. Okay, and if you draw an outward normal at any point location, that is nothing but your n cap. And then they are asking which of the following equations is or are. Okay, so this is very important. This is the point that I was trying to make initially. What happens when students try to solve these questions? They usually miss this this part of the question, and they think it is a single option correct question, and then they solve it completely, but then they realize that I mean, not there, but maybe later when they cross check the exam paper, they realize that they did not read the question correctly, and then even though they knew the answer or they could solve this question, they could not in the exam. Okay, so don't do that. So this is a multiple options correct question. It can be 1, 2, 3, 4, or any combination of these 4. Okay. So which of the following equations are equivalent to this equation? Del rho by del t plus divergence of rho u equal to 0. So if you don't know, this is nothing but the famous continuity equation in differential form. So basically it ensures mass balance across your control volume. Okay, so this is a very famous equation. If you don't know what is this, that is also fine, as long as you can solve this problem. Okay. So let's take this question, this equation, which is del rho by del t plus divergence of rho into u equal to 0, which is nothing but product of density and like local density and or instantaneous density and instantaneous velocity at a particular point at a particular time. Okay. So now, if you look at the options, there are some volume integrals, right? If you look at the LHS of all the options A, B, C, D, all of them have volume integrals. So that is your first hint how to go with this. Go ahead or proceed further with this problem. You need to integrate this differential equation on the both sides over a some volume V. Okay, so integrating let's say equation 1 over a volume capital V, and they are talking about it in the in this question also, that V is some arbitrary volume which is enclosed by closed surface S. Okay, so that should be your first hint. Okay, so del rho by del T plus divergence of rho U will be dV here, and RHS will be 0 only, because when you you know integrate 0 with respect to any volume, it should be 0 only. Okay, so now what you can do, you can split the two terms. Therefore your volume integral, okay, 1 second. So your volume integral will be divided into two, split into two parts. First term will be the time variation of density, and then integral of then volume, then its volume integral. Second term will be this divergence term, right? So if you look at the options C and D, here only you can see, right, the equation that we have written is nothing but option C, no? This one. Okay, so we have not done anything. We have just integrated it over a volume V and just split the term, and that gives you the option C. So option C is one of the answer. Okay, just they have taken this divergence term on the RHS, so that's why negative sign comes there. Okay, so that part is understood. Okay, so option C is there. So if option C is correct, that means option D is incorrect, right? Because they are like both of them cannot be true at once. So now we are stuck with, or we need to verify A and B. So then, since the hint is in this question itself that this volume V is enclosed by a closed surface S. Okay, so this itself should give you the hint that we need to use the divergence theorem here. Okay, so because divergence theorem talks about surface integrals and converts them into volume integrals. Okay, so that is this we have studied in vector calculus. Okay, so if you had attended our regular class, you would have easily solved this question. Okay, so since you want to convert this volume integral into surface integral, you need to use this divergence theorem, or Gauss divergence theorem also they call. So I'll just call it as divergence theorem, but it is also called as Gauss divergence theorem, doesn't matter. So this uh, this second term, because in all the options the first term is same only, the RHS is the one that is that is to be checked. So we'll take this second term with the divergence of rho U. Okay. So we are interested in converting this volume integral into a closed surface integral, right? Because in the options it is surface integral, and S is a closed surface. They have already given that in the options. Okay. So if you uh, you know if you know the Gauss divergence theorem, this translates to multiplying the quantity which is in the which is there to be, which is with the divergence operator, with the unit uh, area normal, or unit normal vector across that surface S over the elemental area ds. Okay, so this is the standard definition of divergence theorem. I have not done anything new here. You could just check it, but it basically converts surface integral over closed surfaces into volume integrals over the volume that is bounded by those surfaces. Okay, so therefore you can write this first term is as it is, del rho by del T dV plus rho U into n cap ds equal to 0. Okay, and now if you go back and check the options, you'll see this means this first option is correct, and A and B both cannot be true together. So either A has to be correct or B. So here A is correct. Okay, so this is how you should solve these type of questions. Okay, so first you need to understand what you are doing, whether it's a surface integral to volume or line integral to surface. Accordingly, you have to use Gauss divergence or Green's or Stokes theorem. Okay, so this is your option A. So the final solution to this problem was A and C. Okay. So it's a classic question, and this is also called as integral form of continuity equation, used in various fluid mechanics or any other many other actually technical fields. Okay. So it was a straightforward question with the application of Gauss divergence theorem. Okay, so let's take the next question. And before we move on to this question, I would just give you a reminder that this divergence theorems or this vector calculus theorems, uh, which include Gauss divergence, Green's theorem or Stokes theorem, every year at least one question is asked from them in engineering mathematics. So you must remember those or prepare for those when you go for your exam. Okay. Okay, so let's go to the next question, which is question number 30. So it says let R and R cube, so 1D real space and 3D real space, denote the set of real numbers and 3D vector space over it respectively. Okay, this is standard definition of R and R cube. The value of alpha, which is unknown, for the set of which the set of vectors, 3 vectors are given, does not form a basis of R cube. Okay, so now here is the concept of basis, right? So see, set of vectors will form basis only if they are linearly independent of each other. Okay, so that is the basic idea. If you know this property of basis, then you would easily solve this question. But if you don't know what basis means, then you can't proceed with these type of questions, right? So in our Cartesian coordinate system, we basically take 1 0 0 0 1 0 and 0 0 1. So these are unit normal vectors along x, y, and z direction. So since these are linearly independent of each other, they form a valid basis. Okay. So similarly, they have given you these 3 vectors and they are asking you to find alpha for which these will not form a basis. So that means these 3 vectors should be linearly dependent on each other. Okay. So in this type of questions, you need to understand one more thing that comes from your linear algebra syllabus, that if you form a matrix with 3 linearly independent row vectors or column vectors, the determinant will be always non-zero. Okay, so what I'm saying is, for example, valid basis requires 3 independent row or actually I should just say vectors. Okay, 3 independent vectors, since we are talking about R cube space. Okay, so we are talking about R cube space. If it is R square, then it will be 2 independent vectors. If it is R4, then it will be 4 independent vectors. Okay, so valid basis requires 3 independent vectors and matrix with 3 independent vectors as its rows or columns will form a full rank matrix. Okay, so this is the property of matrices. So rank of matrix is nothing but number of linearly independent rows or columns. So this also means if your matrix is full rank matrix, this also means determinant of this matrix will be non-zero. So it will be a non-singular matrix. Okay. So now here they want you to find alpha such that it does not form basis. That means you need to find 3 dependent vectors. And one way to find that is you need to form a matrix with these vectors and you need to make the determinant 0. That means these vectors are linearly dependent, and that means that it will not form a valid basis. Okay. So therefore, let matrix, we define matrix A. So we'll take these 3 rows as the rows of this matrix: 2, 3, 2 minus 3 alpha, 3 minus 1, 3, and third row will be 1 minus 5, 7. Okay, so this is what your matrix look like. And now, if determinant of this matrix A is 0, that means row vectors are linearly dependent. That means uh, they cannot form a valid basis in 3D space, 3D real space. Okay, so therefore you need to make this determinant 0 now. So let's calculate the determinant of this matrix A. That will be nothing but 2 into minus 7 minus becomes plus. This becomes 3. 21 minus 3 plus alpha into minus 15 plus 1 equal to 0. Okay, so this term is 16. This is 18 into 3. That will be 64, right? If I'm not wrong. No, 18 into 3, right? So 44. Oh, 54. Not 44. Sorry. Yeah. And then you have alpha into minus 14 equal to 0. So let's go to the next slide. So 16 plus 54 is 70. 70 minus 14 alpha equal to 0. That means alpha is 70 by 14. Alpha is 5. Okay. So if alpha is 5, that means they are linearly dependent vectors and they will not form basis. Okay. So they can change this question and they will ask you what is the value for alpha for which these vectors can form valid basis. In that case, the answer would be any real number except 5. Okay, so when alpha is 5, they won't form basis. But if alpha is any real number other than 5, they will form a basis. Okay, so that is how you are supposed to solve this type of questions. Okay, so these are very like classic questions from the topic of linear algebra. Okay, so yeah, so let's go to the next question. Okay, but here if you can connect this concept of basis with independency of vectors and then with matrices, then you would easily solve this question. Otherwise, this is not easy question. Okay, so let's go to the next question. This one was slightly difficult one in the exam hall. Okay, because it usually you have some idea for other questions, but this was like purely geometry based question. If you know, otherwise it will take some time to do that. Okay, so they are saying that consider Earth to be a perfect sphere of radius r. Okay, so let's see. Maybe we can assume this is a 2D projection of your sphere. Then the surface area of region enclosed by 60° north latitude. Okay, so if this is your equator, which is 0° latitude. Okay, so this will be your north pole. It will be 90° north. The latitude will be like this. So what they are asking is if you join the region, it should be a circle like this, and it will be at the 60° north latitude. Okay, and that contains north pole in its interior. So you need to find the surface area of you typically like this curved surface area, right? This curved surface area you need to find, because they are asking you to find the surface area of your spherical Earth between the latitudes 60° north till and including North Pole. Okay. So first, that is the question. You should not make any mistakes in this concepts of latitude, longitude. Okay. So now, see, for the whole surface of sphere, we know 4 pi r square, but this is the part of this sphere, right? So now, how to go about this? So this is slightly tedious one. Okay, not to worry about it, but let's try to solve this mathematically. So you'll have a, let's say this is your coordinate system. Let's say this is your x, y, and z axis, and it is at the center of the sphere is at the origin. So if you have a, let's say, elemental area over the surface uh, of your sphere, you know mm, this elemental area is nothing but, see, in spherical coordinate system there are three important coordinate systems or coordinates. So x, y, z is there, but usually we prefer spherical coordinate system because then the integrations etc. are easier. Okay, because this question, if you try to solve it by uh, xyz coordinate system, it will be very difficult. So spherical coordinate system is more easier here. So this, instead of solving this in xyz plane, you can solve this in r theta phi plane. Okay, so r is nothing but radius of your sphere. Theta is nothing but it is called as polar angle. Okay, so polar angle, so it is basically the angle measured from the positive z-axis to any point, and phi is called as azimuthal angle. Okay, azimuthal angle, and it is nothing but the angle in the xy plane. So if you take the projection of any point onto xy plane, the angle that it makes with uh, you know uh, positive x-axis is called as azimuthal angle. So this goes from uh, see, this polar angle goes from uh, 0 to, no, this azimuthal angle goes from 0 to 2 pi, because then you complete one whole circle in your xy plane, and then this polar angle should go from 0 to pi, because you just when you rotate that circle with 180-degree, the volume occupied will be the total volume of your sphere. Okay, so this is a standard r theta phi plane. So if you just take any elemental area in this spherical coordinate system, it is nothing but rd theta. So this is nothing but the one side of your rectangle, right? R, this is curved sides, no? So r d theta we take. D theta is the angle subtended by the element at the center uh, if you take it from positive z axis. Okay, and then the other dimension comes out to be r sine theta to d phi. Okay, now I mean, if we do this in the current class, it will take a lot of time, but I would request you to go back and check this derivation. It is available in any standard book. But the thing is, you need to understand that this elemental area, which we typically assume to be rectangle, so one side comes out to be rd theta for really small theta angles, and since this area, elemental area dA, is at the surface, this capital R comes there, and another side you can derive it by taking projections of this point over uh, xy plane, and there you get r sine theta d phi. Okay, so this dA typically is r square sine theta d theta d phi. Now, what we typically do to find the surface area of your sphere, what we do is we integrate. Okay, so typically, the surface area of your sphere, we typically integrate this phi from 0 to 2 pi, theta from 0 to pi dA. Okay, and that's how you get the answer, which is 4 pi r square. But here in this question, they are not asking us to find the whole surface area, right? So they just want us to find the cap of this surface area. Okay, exactly. So in that case, now you need to again go back to the geometry, this geometry, right? So again, okay, so maybe some sphere like this. So let's take the this type of cut will be there, right? When you have uh, theta of 60 degrees. Okay? Or maybe I just call it as 60-degree angle. This angle is 60 degree. So this angle will be 30 degrees, right? And now thing is we need to find this surface area, which is uh, you know enclosed by this purple thing. So in this case, here you are, since you are on your uh, surface, this one coordinate will be capital R always. There is no doubt there. Phi will always go from uh, you know 0 to 2 pi, because anyway you are traversing a full circle in your xy plane. But here the theta, the integration limit of theta, it will go from 0 to 30 degrees only, because you are just traversing this much. Okay, so that is the main concept. If you understand this point, then it's just a matter of doing the double integration. Okay, so this is the point where many students might have made mistake. So instead of taking theta as 60 degrees, because 60 degree is with the equator, 60 degree north is with the equator, but we are interested in because the polar angle is measured from the positive z axis, so that angle we need to take when you do the integration. Okay, so therefore your surface area of the desired cap, I'll just call this area as cap, let's say, because it resembles cap, would be nothing but integration theta from 0 to 30 degrees is pi by 6, and 5 goes from 0 to 2 pi, right? So that means, and then you have r square sine theta d theta d phi. Okay? So now you need to solve this integration. So this phi limits, they are easy to put because the integrand doesn't have any phi uh, uh, this thing. So it will be just 2 pi 0 to pi by 6. R square also comes out of the bracket since it's a constant. Then it just becomes sine theta d theta. Okay. So sine integration is minus cos. So we have 2 pi r square minus cos theta going from 0 to pi by 6, the limits. Okay. So let's take this minus outside. So this becomes minus 2 pi r square cos pi by 6. Okay, so cos pi by 6 is cos 30. That will be root 3 by 2. And minus cos 0 is 1. Okay, so this will be nothing but 2 pi r square 1 minus root 3 by 2. Okay. So let's check the options. What are the options that we have? Okay, so Yeah, we'll just convert it into pi r square by 2, so that will be easy to see. Okay, so this 2 gets cancelled, and this is 2 minus root 3 inside the bracket. Okay, so that is which option? Oh, that is first option only, right? 2 minus root 3 pi r square. Yeah, so this is option A. Okay, so I would say this was like slightly difficult question considering the time that you have in your exam. If you don't have enough time, it will be difficult for you to solve this question. But if you understand this basic concept of doing the spherical uh, geometry integration of r square sine theta d theta d phi from 0 to 2 pi and 0 to pi by 6, not pi by 3. Okay, so this was very important point. Okay, then you should easily get the answer. Okay, so this was one of the tough questions, but I think it's it's not that difficult also. It's just that in the exam, if this clicks, then you will be able to solve it. If it doesn't, then it will take some time. Okay. So, so yeah, before moving on to the next question, there could be another versions of this. Okay, so uh, you know what they can do is, see, this was related to surface area. They can ask you volumes also. So in that case, what happens? This R, the capital R that we take now, capital R square sine theta d phi, that also becomes variable. So it can go from 0 to capital R. See, small sine theta d phi, and it goes from 0 to R, and theta goes from 0 to pi, and phi goes from 0 to 2 pi. Okay, so they can frame the same question, and they can ask you to calculate the volume of this cap also. So it's not like only surface area they can ask you volume also. So you need to that will be like a 3D or volume integral. Okay, you can try it on your own. You can try to calculate the volume of this cap also, so that you'll have some practice, and in future they ask something like this, you would be ready to answer. Okay, so now uh, let's take the next question. Yeah, so this is question number 43. So this is a question related to complex variables and integration of complex variables, because in this question they are mentioning that let z be a complex variable, and if f of z, which is pi z square minus z square into z minus 2, this is the function definition, and C is the circle in complex plane with z equal to mod z equal to 3. So this you should know, this is equation of circle in complex plane where the radius is 3. Okay. So this is mod z equal to 3, and this radius is 3 actually. Okay, so in complex plane, mod z is nothing but root of r square, root of x square plus y square. So here x square plus y square equal to 9. So that will be nothing but a circle centered at origin with radius 3. Okay, and what they're asking is you need to find the value of this f of z dz integral along this closed contour C. Okay, and since they have not mentioned any direction of this contour C, by default, or by conventionally, you take anti-clockwise direction, which is a positive direction. Okay, so the nomenclature is anti-clockwise rotation is positive along the curve, and the clockwise traversing is considered as negative. Okay, so this is a classical application of residue theorem. So you need to first find poles, and if these poles lie inside this circle of radius 3, then only they will have non-zero residues, and then you need to sum up all these residues wherever you have poles and multiply that with 2 pi I, and then you will get the answer to your question. Okay, so this integral along the closed contour C, f of z dz, is nothing but 2 pi I into sum of all residues lying or one second, sum of all residues within this circle of radius 3. Okay, so sum of all residues of poles of different poles within this radius. Okay, so now you should know the concept of pole. So basically, wherever your function goes to, like it becomes undefined, or it blows up, approaches plus infinity or minus infinity. Those points are called as poles. So here, if you pay attention to this, uh, this f of z is nothing but pi z by, there is one this mistake is there. Okay, this typo is there. It's not pi z, it is sin pi z. Okay, so this is sin pi z. You can refer to the original question paper on the original website also. It is not pi z, it is sin pi z. Otherwise, this zz will get cancelled. No? So it was not that, there was a typo. So sin pi z, z square, z minus 2. Okay. So, there are 2 points, at z equal to 0 and z equal to 2. This f of z value tends to infinity, right? Okay. So therefore, these are the poles. Therefore, these are the poles. And they lie inside this circle of our integration, or this region of integration of radius, circle of radius 3. So therefore, we cannot neglect their residues. We have to take the residues into account. Okay, so if you look at this, this z equal to 2 is a simple pole, because just one term with power 1. But this z equal to 0, since it is a z square in the denominator, it is a repeated pole, or they also call this as, or it is also called as pole of order 2. Okay, so the procedure to calculate the residue for each of these poles is different. That's why I'm mentioning that there are different types of poles. Okay, so simple poles, as the name suggests, they are easy to deal with. So let's calculate the residue at this simple pole z equal to 2. That will be uh, residue at, let's say, z equal to 2. So it is nothing but limit z tends to 2, z minus 2 into f of z. So this is the standard way to deal with these type of questions, or simple poles. So if you put sin pi z divided by z square into z minus 2, that z minus 2 gets cancelled, right? So this only remains pi z by z square. Okay, so now you have to put z equal to 2, so you get some finite number. So this will be sin 2 pi by 4. Sin 2 pi is 0, so residue is 0 at this simple pole. Okay, now residue at z equal to 0, which is repeated pole. So here basically you need to, if it is a pole of order 2, repeated pole of order 2, you need to differentiate once this function. Okay, so what I mean by that is, the residue at z equal to 0 will be limit z tending to 0. Since it's a second order pole, you need to differentiate once. If it is third order pole, you need to differentiate twice. Okay, and then you will have z square into f of z. This is the critical step. If you remember this, then you will be able to solve this question easily. Okay, so then this z squares get cancelled. this becomes limit z tending to 0 d by dz of sine pi z divided by z minus 2. Okay. So now you need to differentiate this function. Okay. So you need to use the u by v rule. Okay. So d by dz of sine pi z divided by z minus 2. Okay. So u by v rule. So that is equal to z minus 2 square z minus 2 into differentiation of sine. So sine pi z, so that will be cos pi z into pi minus sine pi z as it is into differentiation of z minus 2, that is 1. Okay. So what do we have here? It is nothing but z minus 2 pi is there, cos pi z minus sine pi z divided by z minus 2 whole square. Okay. And then you need to apply the limit. So to find the residue at z equal to 0, it is limit z tending to 0, this function, this whole. Okay. So I'm not writing it again because it will take some time, but you get the point, right? The differentiation function we need to put, and we need to put z equal to 0 in this function. So denominator becomes 0 minus 2 square. This becomes pi 0 minus 2 cos of 0 minus sine of 0. Okay. So sine of 0 is 0, cos of 0 is 1. So numerator you have minus 2 pi divided by minus 2 square is 4. So this is minus pi by 2. Okay, so that is the residue at z equal to 0. So therefore, the total integral value along this closed contour circle of radius 3 is nothing but 2 pi I, and the residue at 0, z equal to 2 is 0, plus residue at z equal to 0 is minus pi by 2. So 2 gets cancelled, so it is minus pi square I. So if you look at the options, yeah, they have not mentioned it as I. This I and J, these two terms are interchangeably used to represent iota, which is square root of minus 1. So therefore, this last option, option D, is the correct one because you get minus pi square into I. So option D is the correct answer. Okay, so again, I would say this residue theorem is also very favorite topic of examiners. What they do is typically they will change the nature of this f of z. Sometimes it will be easier function to differentiate. Sometimes it will be hard. They will try to confuse you with these things. Um, uh, you know, these types of poles. Okay, so sometimes uh, it will be simple pole or repeated pole. So you need to remember how to calculate residue for these things. And many times they confuse you because see here it was this closed contour C was a circle of radius 3. If your poles lie within this radius of 3, then only you should consider their residues. If the pole lies outside of this z equal to 3 range of the circle radius, then it won't contribute to your integral. Okay, so what I mean is, if instead of z minus 2 in the denominator, in this question, instead of z minus 2, if they have given you z minus 4, that means z equal to 4 is a simple pole, but it lies outside your circle. So therefore, you should not consider its residue. Okay, so that's how you should. These are all the traps that can be set in these type of questions. Okay, so now let's go to the next question. So It's question number 54. And they have mentioned that there are three functions, f1, f2, f3, functions, 3D functions, x, y, z parameters they take as inputs. And suppose that for every given pair of points A and B in a space, in this 3D space, this line integral of f dx, f1 dx, f2 dy, f3 dz evaluates to same value along any path C that starts and ends at B. Okay. For example, if let's say this is your point A, point B. So what they are saying is line integral of this integrand evaluates to same value along any path. Okay, so let's say this is your path 1, and you do the integration along this path, and you do another integration along this path, let's say 2. This value of integral along, I'm not writing that whole thing again, but what they are saying is when you integrate this function along these paths, their value is always same. Okay, so not only this 1 and 2, you can take any path, their value is coming out to be same. Then which of the following statements is or are true? Again, multiple choice question. Okay. So now this is actually a very big hint that this integral, so this integral f1 dx plus f2 dy plus f3 dz is path independent, right? That's what they mean, right? Along any path you take the integral, the value is coming out to be same. That means it's a path independent integral. Okay. And if you pay attention to this, there are these three functions are there. Okay? F1, F2, F3. Okay. So so now like I know that this represents a conservative field given by a vector. What I'm trying to say here is, if you define, let's say f bar, which is a vector function with f1 x cap, let's say f2 y cap, f3 k cap. Okay, so x cap, y cap, k cap, or I should say k cap, z cap. These are unit normal vectors along x, y, z directions. And let's say I denote, let's say, this dl line element as dx into x cap plus dy into y cap plus dz into z cap. Okay, so in that case, the integrand that you see, this function, is nothing but f bar dot dl. Okay. So what I'm trying to say here is, if we assume that there is one vector function whose components are f1, f2, f3 along x, y, z directions, then the integrand represents nothing but this dot product of f dot dl along that path. Okay, and it's independent. So this also means, if you are familiar with concept of conservative vector fields, if this integral, if this integral is path independent, that means this f bar, which is a vector function, with each individual components f1, f2, f3, represents a conservative vector field or space, whatever you want to call it. So the main keyword here is conservative. Okay, so you might have come across these terms in your undergrad. This gravitational field is conservative field, electromagnetic field is conservative field. Okay, so that is what it means. Okay, so if you understand this concept, then it is straightforward, because uh, now you have to go by options, because it is a multiple choice correct answer. But what I'm trying to say here is, uh, these there are different fields which are conservative. Okay, for example, gravitational, electrostatic. Okay, so uh, you might have come across this field, this term, which is called as conservative force field or conservative vector space or vector field. That means that if you designate this field by a vector function f bar, and if you take the dot product with the elemental uh, length vector, that integration along any path between 2 points will be will give you same value. So that means it's a path independent function. Okay, and then they defined, they call this as property, etc. But let's not go there. Just make sure that you understand this is a conservative vector field, and then you should go by options. Okay, so there are certain properties of conservative vector field, and that include, first, as it says, the line integral along any path is any along any path between 2 points is line. This integration is path independent. Okay, so therefore let's take option A. Okay, so option A says for every closed path uh, lambda, capital lambda, I think, we have this value of integration equal to 0. Okay, so what they mean is closed path lambda. So let's say you define this closed path as like this. So you have point AB, and then you close the curve with another part which is lambda 2. So the whole thing is called as lambda. So that means this integration along lambda of f bar dot dl is nothing but integration along lambda 1 f bar dot dl plus integration of along lambda 2 f bar dl. Okay, and since these are path independent integrals, so therefore this value, if this first integral along path lambda 1 is, let's say, a, then this will also be lambda only, a only. This second integral will also be a, but it will be with a negative sign, because you are traversing from b to a. See, lambda 1 you are going from a to b, but lambda 2 you are coming from b to a, right? So this will be minus a. Okay, so therefore this integral of complete integral will be a minus a equal to 0. Okay? A can be any value, doesn't matter, but the main thing is the cyclic integral or the integral along any closed path is always 0 for a conservative field. Okay, this f dot dl. And the same concept we use in when we call gravity as conservative field. We say that work done is 0 when the net displacement of any object is 0 in the gravitational field, right? So that f bar represents your weight, mg of the object, and then displacement is represented by the dl vector. When the net displacement of any vector or any object is 0 in a gravitational field, that work done is also 0, right? This you must have seen in your undergrad or +2. Okay, so that is the application, that net work done is 0 when the path is, so basically you return to the same path from where you started in a conservative field. Okay, so therefore option A is correct. Okay, and then you know yeah, this option B is nothing but it's a property of your this thing, conservative vector field, okay, which says that you know any you know, any conservative field f bar can be represented as a gradient of a scalar function. Okay. So let's say we call this function as some phi, okay, scalar function. That means f bar can be written as gradient of phi. Okay, and you know this is called as scalar potential function. Okay, so for any vector field, there always exists scalar potential function. Okay, and we use these concepts when we solve for you know streamlines and equipotential lines, all those things. So this is actually a property of conservative vector field, that it can be represented as a uh, uh, differentiable as a gradient of a scalar function f. So that phi that I have written there is nothing but um, this f of x y z. Okay, so what I have written in the subsequent slides is nothing but this one. Okay, so instead of phi, I should just put small f there so that there will be no confusion. Okay, grad of f. Okay, so then if you compare the element wise comparison, so this will be del f by del x, f2 will be del f by del y, f3 will be del f by del z. Okay, those things you can just do comparatively. Okay, so this is also correct, this is also correct. Now let's see the option C. It is nothing but this del f1 by del f x, del f2 by del f. So uh, this for this vector field f bar, if I take its divergence, that will be nothing but del f1 by del f del x, del f2 by del y plus del f3 by del z. Okay, so they have given this term only in the question. This third option represents that the divergence of your vector field is 0, and you know that is not 0 always. Okay, I mean there are two cases actually. See, this divergence will be equal to 0 only if it is incompressible vector space. Okay, and it can be non-zero when it is a compressible conservative field. Okay, so therefore uh, this divergence condition, this divergence of vector field f, it represents more of like it is indicator of this compressibility of your vector field. If it is incompressible medium, then it will be 0, but it is not always 0. So therefore option C is not always true, and therefore it is incorrect. Okay, so in very special case it will be correct, but they have not mentioned anywhere in the question that it's a conservative and incompressible vector field. Okay, so nothing like that has been mentioned. So option C is not correct because it cannot be always 0. And option D, that's interesting one, because it actually is nothing but the curl of your vector field f, right? We'll see that. So you know, again, the conservative field has a property. It's a property of conservative vector field that for a conservative vector field f bar, curl of f bar which is again denoted by this operator, is always 0. Okay, it basically is a this thing that if you studied fluid mechanics, it's nothing but this curl. It is, when it is 0, it represents irrotational uh, vector field. So conservative fields are always irrotational. So that could be also one of the question. So you should remember conservative vector fields are always irrotational, and great curl of that vector function is always 0. How do you find the curl? Ijk. So then you'll have del by del x. Second. Yeah. I jk del by del x, del by del y, del by del z, and the components of your f bar, they are capital F1, F2, and F3. Okay? And it has to be 0. Then if you expand the determinant, and then since the total vector has to be 0, each element has to be 0. If you do that, what you would get is you will get 3 conditions like this. Del f3 by del y will be, just let me see in what form they are writing in the question. Okay, so they are writing in the equality form, right? So del f3 by del y will be equal to del f2 by del z. Similarly, yeah, del f1 by del z will be equal to del f3 by del x. This is x. And del f2 by del x is nothing but del f1 by del y. Okay, so basically I'm just calculating a determinant of this matrix, and then I will get these 3 equations, because every component of that curl vector has to be equal to 0. Okay, so if you verify, these will match with option D. Okay, so that's why option D is correct. So in this question, A, B, and D options were correct. Okay, C option was not correct because it is not always true. Okay, so this one I would say was a quite interesting question, because it checked all of your knowledge about conservative fields, or in general also. If you could not name it as conservative field, but if you just have this intuition to define a function and then take its dot product with the DL vector, then you would get all these answers. Okay, that should, I mean, that main concept would have given you the idea that it's a conservative field. And then for any conservative field, there is always one scalar potential function, and then curl is 0. Integral along any closed contour or cyclic integral is also 0. So in the cyclic integral concept, it comes in your thermodynamics also. Okay, so yeah, but divergence is not necessarily always 0. So this was one of the more challenging question from the vector calculus topic. Okay, so let's go to the next question. I think this one is the final one. Yeah. So they have given you a matrix, 2 by 2 matrix, 1k, 1. K is a positive real number. So K is a positive real number. Which of the following vectors is or are the eigenvectors? Again, it can be 1 or 2 or 3 or 4. But since it's a 2 by 2 matrix, there will be only 2 eigenvectors maximum. Okay, so at the most, we'll have 2 eigenvectors. So either one option or 2 options could be correct for this question. So the standard way to solve these type of questions is to first find eigenvalues, and then corresponding to each eigenvalue, you need to find the eigenvector. Okay, so that is a standard way. Here, the slight difficulty or the novelty is this: they have not given you all the numbers; they have given you one unknown, which is k. Okay, doesn't matter. The process is the same only. So now you need to first find out the eigenvalues. Okay, so for eigenvalues, The characteristic equation is nothing but determinant of a minus lambda I equal to 0. And this a is this, let's say this matrix, we call it as A. Then you need to do a minus I, lambda I, matrix subtraction, and then you need to take the determinant. So that is nothing but 1 minus lambda. A remains as it is, 2 remains as it is, and this will be, I think, 1k, 2, 1. Yeah, so it will be again 1 minus lambda. This determinant has to be 0. So this is equal to 2k. Okay. So here only you can take the root, right? So therefore this becomes 1 minus lambda plus minus 2k. So this means lambda will be, oh, you have to take the root also. So this will be root 2k. Okay. And plus minus sign will be there, because when you square it, that plus minus sign will also become positive. Okay. So lambda will be plus minus root 2k. Yeah, it will be 1 here. So it will be 1 plus minus root 2k. So therefore we have one eigenvalue which is 1 plus root 2k, and second eigenvalue it is 1 minus root 2k. Okay, so like that you have two eigenvalues. So first half of the question is done. So now you need to find eigenvector for each of these eigenvalues. Okay, so let's take first eigenvalue, which is 1 plus root 2k. Okay, so eigenvector, let v1 be its eigenvector, then this eigenvector is nothing but a minus lambda I into v1. So this will be lambda 1 should be equal to 0. That is how we calculate the eigenvector. Okay, so let's say a minus lambda 1 I. Okay, so this will become 1 minus 1 plus root 2k. This will be k 2. This will be same 1 minus 1 plus root 2k. Okay, and let's say this v1 has components like AB. Okay, we don't know. So our objective is to find A and B. So now, if you just simplify this, 1 gets cancelled. So there is minus root 2k, k 2 minus root 2k equal to AB. This has to be 0, 0. Right? So now you have two unknowns and two equations. Because you can just multiply, right? So this will be minus root 2k into A plus bk equal to 0, and another equation will be 2a minus root 2kb equal to 0. Okay. So now we have to basically eliminate some, like do substitution. So find a from any one of this equation and substitute in the other equation to get the values of a and b. Okay, that is one way, but it is a lengthy way. So what you could do is, in this type of things, is let's take any one equation. Okay, or maybe we'll take, let's say, this one. Okay, so here you will see 2a equal to root 2k into b, and that means a equal to, we have to divide both sides by 2, so this will become k by 2 under square root sign into b. Right, so now we have to look at the options, because this is not a conventional exam, it is a competitive exam. So here there are two options where you could see 2 by k or k by 2, because in other C and D options it is 2k. We are not getting 2k, right? It is k by 2 here. So what you can do is, let's say you put, see, our eigenvector is like this, no, AB. So you can just put A equal to 1, because in both of the options, possible options, A is 1, right? So that's why if you put A is 1, then your B becomes 2 by k in root bracket. That means your eigenvector is nothing but 1 and 2 by k. Okay, and that is option number B option, right? It's not a negative sign, so it's just a 2 by k. So that is your option number B. Okay, so you found one eigenvector without doing much calculations. Just you had a look at your options, and A was 1 in both of the possible options. So we just took A equal to 1. That reduced your time. You can solve this conventionally also. It will give you the same answer. Okay. So now this is for 1 lambda, and this is your only half of the job done. We need to consider another lambda also for lambda 2, which will be nothing but 1 minus root 2k. Let this another vector, maybe CD, be its eigenvector. Then this A minus lambda 2I into this eigenvector, this product has to be 0. That is the property of your eigenvectors. Okay, so now this bracket will become 1 minus root 2 k, k 2 1 minus root 2 k. Some C and D unknowns that we need to find out. 0 0. Okay, so it simplifies to root 2k, k 2 root 2k. Then you have these two equations where it is root 2k into C plus k into D equal to 0. 2c plus root 2kd equal to 0. Okay. So you can take any one of this equation. So let's take the first one. So in this case, this is c equal to minus k by root 2k into d, right? Or you can write c equal to minus k by 2 into d. Okay, so again you are getting under root k by 2. So if you look at any of these options, so see, this C and D cannot be true because we are not getting 2k, we are getting k by 2 or 2 by k. So that means option A could be the answer. So here also the first element of the eigenvector is 1. So just put that. So, put C equal to 1. That gives you D, which is minus root 2 by k. Therefore, your eigenvector, which is nothing but CD, so C is 1, and this is minus 2 by root k, root 2 by k. Okay, so, and that is option A. Okay, so A is also as an eigenvector. So this is your option A. And since you have only two eigenvalues, you will get maximum two eigenvectors. And both of them are in the option. So A and B was the correct answer to this question. Okay. So yeah, I mean, with this, we have solved all of the questions that were asked previously. And most of these types of questions we have already discussed in our regular classes. So if you're interested, you should consider joining. Okay. So a lot of contact information is given here. If you're interested, you should look into this, because engineering mathematics is very important for all the branches. Okay, so anyway, with this I'll stop here, and hopefully see you next time. Okay.